Hello guys, welcome to iTube Physics channel. So we'll move to the next question. So this time the problem is quite different because this time you throw a ball in an inclined plane. So let me explain the problem. So a projectile is launched with 20 meter per second. Okay, so you launch a projectile with 20 meter per second from the bottom of an inclined plane at an angle of 75 degree. So a projectile is launched with 20 meter per second. The angle the projectile makes with the horizontal with respect to the horizontal axis is 75 degree. The inclined plane makes an angle 30 degree with the horizontal axis. Okay, so this is our horizontal axis. So with respect to the horizontal axis, this inclined plane makes an angle 30 degree. So meaning with respect to this inclined plane, this projectile makes an angle 45 degree. So that is the idea. Our task is you need to find the distance traveled by the projectile along the inclined plane. So you need to find, okay, if you throw a projectile with 20 meter per second with angle 75 degree, what is the distance traveled by the projectile along this direction, okay, along this inclined plane. So let me call this distance as d. So my task is to find the value for d. Sorry. So how do you do this? The first step is I'm going to divide the velocity vector components. So remember, this time I'm not going to divide as usual way. Okay, usually I divide in the horizontal direction and the vertical direction, but this time I'm going to divide my velocity vector component in along the inclined plane and perpendicular to the inclined plane. So we said this total angle is 75 and the inclined plane makes an angle 30 degree. So this angle is 45 degree. Okay, 75 minus 30 is 45 degree. So my first idea is to divide this velocity vector along the inclined plane and perpendicular to the inclined plane. So if you divide this, I'll get 20 cos 45 and perpendicular direction is 20 sin 45. So the first step, I have divided the given velocity vector component along the inclined plane and perpendicular to the inclined plane. So this is my first step. The second step is I'm going to divide similarly the acceleration component. Acceleration is always downward, remember, okay, the acceleration is downward. So acceleration is 10 downward. So again I'm going to divide this acceleration. It should be along the inclined plane, other one should be perpendicular to the inclined plane. So how do you do this? So this is my velocity, the acceleration due to gravity is 10. So remember, this angle is 30, this is 100, so this should be 60 degree. So I can divide this acceleration towards this angle. Remember, I said if you divide a vector towards an angle, you have to say cos component. Okay, so you can say 10 cos 60, and if you divide away from the given angle, you can say sine. So if you divide this acceleration component, you will get along the inclined plane, you will get 5 ms minus 2, and in the perpendicular direction you will get 8.66 ms minus 2. So now usually we had the acceleration just always towards the earth, okay, so that is just 10 meter per second, but in this problem we have two different acceleration. So that is a really important factor you need to take into account when you solve this problem. So if you realize these two factors or these two ideas, the rest is simple. You can simply solve the problem. So now I'm going to solve the problem. My task is to find the distance traveled along the inclined plane. So how do you do this? First, let me use s equal to ut plus half gt squared in the perpendicular direction, okay, perpendicular direction. So this is our inclined plane, perpendicular to the inclined plane, and I'm using this for the whole journey. So I can imagine now this projectile is actually going up and come to the same inclined plane. So if I use this for the whole journey, the displacement is 0. So I can say this is 0, and what is the initial speed of the projectile is, here we said 14.14. So this is our initial speed into, let's say the time of flight for the whole journey is big T, okay, so big T minus why minus sign, because we are applying the equation perpendicular to the inclined plane, but the gravity, you see this gravity component is downward, okay, this is downward. We found 8.66 ms minus 2. So minus half 8.66 into t squared. So from here you can take t as a common factor. So if you simplify, you will get 4.33 t minus 14.14, which is equal to 0. So from here I can find two values for t, big T. So big T is the total time of flight. So one is t equal to 0, other one is t equal to 3.27 seconds. So this is our total time of flight. This is time we said the projectile, when you start to throw the projectile, okay. Well, so now if you know the total time of flight, the next step is to find the distance traveled by the projectile along the inclined plane. So how do you do this? I'll use s equal to ut plus half gt squared. Now I'll use along this direction, okay, along the inclined plane. So let me say the distance traveled along this inclined plane is d, which is equal to, we said we divided the velocity component along this direction as 14.14. So here we found the initial speed. So 14.14 into the total time of flight, we found 3.27 seconds, okay. But remember, this time we have an acceleration component along the inclined plane, okay. But what is the direction of that acceleration component? Here we said, you see, we got an acceleration component, but okay, towards down, but we are actually applying the equation upward. So I have to put here minus sign, okay. So you need to be really careful at this stage. So I'll put a minus sign. So half g, we found there 5 meter second minus 2 into t squared is the total time of flight is 3.27 square. So if you simplify this, you will get the distance traveled by the projectile along the inclined plane is 19.51 meters. So this problem is not really complicated. Here the main idea is you should quickly recognize this, how to divide this velocity component, and also in addition, so usually you do this, but you usually divide the velocity component only along the horizontal and the vertical direction, but this time we are dividing the velocity vectors along the inclined plane and perpendicular to the inclined plane. In addition to that, here we are also dividing our acceleration component. So this question is not really complicated if you understand these two ideas. Okay, I hope you got the idea how to solve this problem. So thank you for watching.